Good evening, everyone, and I welcome Dr. Gaurav Kumarji on this faculty development program. Gaurav Kumar is the resource person, trainer, and speaker in the assorted technologies. His credentials integrate MCA, MPhil in the computer science, MTech in information technology, PhD in the computer science, and LLB with more than 24 years of experience in teaching, industry, and research, along with international certifications. So, Dr. Gaurav's area of sessions delivery includes open source libraries, artificial intelligence, web technologies, data science, Python, blockchain, e-tools, and LMS for academia, cybersecurity, digital forensic tools, software testing, quantum computing, and related technologies. He delivers the practical hands-on session on recent technologies in workshops, faculty development programs, short-term courses, webinars, and technical events as resource person in various states of India and associated as jury in national level technical events. So he is further accessible on his website magmaconsultancy.com, and today he will share his expert talk on the title Case Studies and Practical Applications of Data Analytics in the Cybersecurity. So, Dr. Gaurav, are you available here?
Yes, sir. Good evening, sir. Am I
Yes,
audible?
sir. Yes, sir. Good evening, sir. You are audible. Now, sir, you can carry over the session.
Okay, thank you, sir. Good evening to all the participants. We are starting this session. Dear participants, I have shared my presentation. Kindly confirm in chat window, is it audible and visible to all of you?
Yes, sir. It's
So,
audible, and the slide is presentable as well. It's visible.
okay, thank you, sir. So, dear all, in this session, we will discuss about different case studies and practical applications of data analytics in cybersecurity, information extraction using different free and open source platforms. In this particular session, we will cover diversified segments related to information security, cyber forensic, vulnerability analysis, whether we want to analyze a particular web server or we want to go for information extraction and analytics from Android apps. As nowadays we are in the era of IoT, Internet of Things, and in IoT scenario, you might have seen that we use different types of gadgets, wearables, and almost everybody using Android or iPhone. So how much we are secure in this particular segment and by which way we can extract data related to security and privacy, and how to make sure about different platforms whether these are secured or not by information extraction. In this session, I will try to cover different domains related to this particular implementation, including zero-day exploits, network analytics, lateral movement or graph evaluation. However, this particular topic is very, very broad, very diversified. Still, we will see to some extent how to make use of very high performance platforms for information analytics. With machine learning or deep learning, we can work with, we can go for direct data extraction and analytics. One by one, we will see different case studies different case scenarios where we can work with cyber security based applications. Very first segment in this session related to information extraction and data analytics. We will cover related to Android apps. How to extract data, how to fingerprint any Android platform, any app, and by auditing of these apps, how to ensure that we are in secured environment. You might have seen that nowadays lots of apps are available, and you might have seen that specifically youngsters, school or college going students, they are more diverted towards the fintech apps or bidding apps, whether it is My 11 Circle, Dream 11. Okay, so many, you might have seen that hundreds of apps available nowadays on Play Store, and beyond Play Store also lots of apps are deployed. But can we make sure that these apps are secured or not? Whether we are in safe environment or not? I will show you some demonstrations by data extraction, by fingerprinting of Android apps. So in first segment of this session, I will cover fingerprinting data analytics from Android apps and how to make sure that whether these apps are secured or not, whether these apps are safe or not. Why we are taking this scenario? Because you might have seen that on same mobile phone we are using UPI, NEFT, net banking apps. On same device we are working with fantasy or betting bidding apps. And many times you might have seen that even if we are having antivirus or firewall, even then mobiles are hacked. So what a particular antivirus or firewall will do, if we are working with a particular app, if we have installed one app that is extracting each and everything at backend in sniffing mode, in passive mode, in cybersecurity, in information extraction, you might have heard about two terms, active attack and passive attacks. Okay, everybody, you might have seen that everybody is aware with active attacks, everybody can guard against active attacks, but what about passive attacks, which are not visible, which are going on at the back end? As soon as we click on some particular link, as soon as we install a particular app in our phone, and if that particular app is sniffing data, then no antivirus of this world can save that particular device. First of all, I want to make this point very much clear that I'm not against any particular platform. We are not against any particular company. These companies, these names we have mentioned here, only for example, just for explanation, teaching, we are not against any particular organization or company. Okay, so this is my disclaimer. I will show you some demonstrations by data extraction, and we will see by which way we can check the backend script, backend data with any mobile app. When we work with this particular case study related to Android app analysis or IoT gadget analysis, because you might have seen that nowadays so many gadgets available, wearable devices. On those wearable devices like smartwatch, on smartwatch or smart wearable, you might have seen that Android app can be installed because they provide this feature to install from Google Play Store. Even you might have seen that in our vehicles, in cars, we are using Android display for maps, okay, or for video or music rather than classical music player. And on same particular gadget, on same display, we are installing some haphazard apps. Then how much probability will be there for sniffing of your data, for sniffing of your exact location, where you are moving. So we will see few implementations related to apps data extraction. As far as apps data extraction is concerned, data analytics of Android apps are concerned, this particular segment comes under a particular technical domain that is known as reverse engineering. Using reverse engineering, we can move inside any platform and we can see which type of script, which type of data is trained. For example, you have a machine learning model, you have one app that is having some trained model, and I want to see that trained data. It can be done, it can be viewed by reverse engineering. And it is not illegal because many times this question may arise that whether it is legal or illegal. For example, I'm having one app of Paytm or Google Pay. I want to see backend code or backend data, which is flowing, which is working at the inner level of that app. We can penetrate any app by some free and open source toolkits. And these toolkits are for teaching and research only. Okay, not for penetration, not for any sniffing part. So reverse engineering means decompilation. We have one object code, we have one final code, and from that final code, we want to generate the base file with data. That is app decompilation. And using app decompilation, using reverse engineering, we can move inside any code of any app. But first of all, we should be clear about the architecture, because if we want to sniff, if we want to penetrate the data, if we want to penetrate the script of any Android app, obviously we should be clear about its architecture. So as far as Android apps are concerned, these files, these are available in form of APK format. You can see Android package. This is known as APK. Okay, APK file. Whatever package, whatever software we are installing, whatever app we are installing in our mobile phone, at backend it is in APK format. And in every Android phone, there is a virtual machine that is known as DVM, Dalvik Virtual Machine. As far as Android is concerned, you might have seen, you might have studied if you are going through the programming part that it is Java enabled, but majorly it is enabled with Dalvik Virtual Machine, DVM. So broadly, we can say that each and every Android phone is having Dalvik Virtual Machine. Onto Dalvik Virtual Machine, we run APK files. If we remove the files, if we remove the executable of DVM, then your APK will not run, whether it is Paytm, PhonePe, or whatever it is. In traditional Symbian phones, JVM is working and onto JVM we have to work with jar. Okay, but nowadays you might have seen that Symbian phones or classical phones are not available. Okay, so if I want to penetrate the data inside any Android app, we have to see inside APK file. And you can see that. So these few concepts we have written here. In case of smartphones, we use Dalvik virtual machine, and onto Dalvik virtual machine, APK is executed. Each and every APK is having DEX file, Dalvik executable. Okay, so no need to worry about these technical parts. I will show you its direct demonstration. Okay, but it is only for the explanation by which way DEX file is executed, by which way smartphone apps works. Okay, on classical laptops, on PCs, we work with JDK, we work with Java virtual machine. If I want to work with a particular software, I want to penetrate a software in terms of data, then we take a particular Java file, and that particular Java file needs JVM, Java virtual machine, Java runtime environment. Okay, in case of smartphone, we work with DVM, every Android phone. So by which way we can see a particular app? So first of all, we will see which platforms are available for data analytics. APK Pure, so you can see APK Pure. You might have seen that many times nowadays it is happening. For example, some particular app is banned by government agencies. Such apps are available on alternate sources. At the time of lockdown, you might have seen TikTok was banned. Okay, so many other apps, but these apps are available here. So you can see here on these platforms, APK Pure, APK Mirror. So thousands of apps available, platforms available, APK Mirror, from where specifically youngsters, specifically young generation, they take the different types of games. So we will see by data extraction, by APK analysis, whether these apps are secured or not. Because from Google Play Store, why I'm showing you these platforms? Because APK file can't be downloaded directly from Google Play Store. If I want to check APK file of WhatsApp, if I want to see APK file of PhonePe or Google Pay, then I will have to move to these platforms, APK or APK Mirror, thousands of toolkits available. You can see that. And here you will get different variants of apps. Okay, so you can see that. So if I want to take WhatsApp, you might have seen at some particular time, Zoom cloud meeting, it was also banned by government agencies because it was identified that data leakage is there. So you can see WhatsApp Messenger, I can download its APK file. But if I want to download APK file from Google Play Store, it is not available. Okay. They will give its executable only. Okay. Now few particular APK files I have already downloaded. So if I want to fingerprint, if I want to go for data extraction, if I want to see whether these apps are involved in data leakage or not, then we have to work with some specific toolkits. So dear participants, first of all, kindly confirm, is it audible and visible to all participants till now? Is it clear to all participants till now, whatever we are discussing? And audio and screen is visible to all.
खत्म हो गया वो
Kindly confirm.
one
Yes, sir,
In
it
chat.
is visible and clear. Your audio is clear. Sometimes the noise is generated, so that we are identifying to mute.
Okay, okay, otherwise it is clear. Okay, so okay, just a minute. So so some apps I have already downloaded for demonstration. For example, one fintech app, this APK file I have downloaded and I want to go for its fingerprinting. So we will see which platforms are available. So all of these links I have given in this presentation, APK combo, and you can go for that. Okay, you can download any app's APK file. Okay, now we will see which particular toolkits are available for data extraction and fingerprinting. Okay, APK tool. Reverse engineering tool, and some apps we will take for demonstration. These toolkits are free and open source. So whatever tools I will cover in this session, all of these are available in free and open source distribution. So you can see what we can do: assemble, disassemble, and using these tools, cloning of apps are also done. Okay, so I will not cover that particular part, cloning of apps. Okay, we will cover that particular part which is related to fingerprinting, data extraction, and information analytics. APK tool, it is command based. If we want to work with graphical user interface based toolkits, these are also available. You can download this and it will be available in form of zip file. Okay, so you can see that. So I will show you one demonstration. Android AAPT, another toolkit for data extraction, Android AAPT. So I will show you. So after downloading this particular software, it will be available in this format. So you can see that this is my command window. In this command window, AAPT toolkit, this particular platform, this particular free and open source software I have downloaded for data extraction from Android app. Few APKs I have downloaded for demonstration. One, Zoom Cloud Meeting. It is only for demonstration. Opera Mini web browser. This one is bidding app, Noah Cash Club, Google Play Music, and Dream 11. These apps are only for demonstration, only just for teaching or data analytics. Another utility, Dex dump, that is also available. Okay, so in my presentation in this PPT, each and everything is given. Every link I have mentioned. At the end of this session, I will share this presentation to all of you so that you will be able to work. Okay, now we will see. First of all, we will discuss what we are going to do. For example, one particular app is not available on Google Play Store. It is available on alternate source. It is downloaded from alternate platform. If we will directly install that app in our mobile phone, you can imagine what may happen to your phone if it is sniffing data, if data leakage is there. So before installation of any app, we want to fingerprint it. We want to extract information, interior information from that platform. So APT D. So by simple commands, permissions. I want to see permissions associated with any APK without installation. If we are downloading and installing from Google Play Store, you might have seen that lots of mechanisms available They provide permissions, but interior scripts are not provided. Using this tool, you will be able to penetrate into interior script and data. I want to see permissions associated with this app, which I have downloaded. So you can see APTD permissions, D for dump. I want to display. This one is for dump. So before installation, I can fingerprint it. I can extract its data. It's XML data. This particular data is available in XML format at the time of development of that app. When developers were working on this app, they saved this particular information in XML file. So this is XML fingerprinting, APK fingerprinting, and we can see which permissions are associated. Read, write, external storage, memory card, access network state, Wi-Fi state. Okay, download without installation, one of the very dangerous permission. Okay, without your notification, without any permission, without asking okay or cancel, it will start downloading some service, and you can imagine what may happen after that. In same way, another, for example, we want to see for Zoom cloud meetings, APTD permissions, so many permissions, Bluetooth admin. Okay, so as soon as this app is saved in your device, then which type of data can be sniffed, which type of data can be leaked out. Access file location, access course location. It means each and everything. Okay, use fingerprints. Use fingerprint. Using same fingerprints, we are working on mutual fund trading, on stock trading, on same fingerprints, or using same fingerprints, some particular app is playing with your data. Okay, so you can see that request install packages, access, okay, and so many other services. So this is data extraction, direct data extraction, and it is not illegal. First of all, this point should be known that it is not illegal what I'm doing, because it is only fingerprinting, it is only data extraction. Okay, we are not manipulating any data, we are not pushing any data on cloud, we are not overwriting data on actual app. Okay, it is only fingerprinting part. If I want to move into script, APT permissions, so resources, and APT resources, which is for which app? Zoom cloud meetings. If I want to see the backend data, which type of payload is inserted at different key points. So if you are aware with Android programming, then you can see this particular information. Strings. So all of these commands are available in its official documentation. Which type of scripts are available? So each and everything. So this is known as, this particular implementation is covered under partial decompilation. We are partially decompiling this app to see which type of data is associated to which particular platforms it is linked, and which are the probable vulnerabilities. Okay, so in same way, Google Play Music, any, you can take any of these, you can analyze. So you can directly download any app and you will be able to work with it. Okay, APK tool, or you can take APT D, Android APT. So these screenshots I have given in this presentation. So you can see that these are the screenshots by which way you have to work. I have recorded all screenshots in this platform, in this PPT, and you will be able to work with it. So this is partial decompilation, partial data extraction. If we want to extract complete data, full decompilation, okay, so this is dex dump utility, okay, to see the backend script. And now we will see the platform that is used for full decompilation of any smartphone app. It is also under free and open source distribution. This one. If I want to see each and every script associated with that app, each and every script means whether it is saving credit card data or UPI data in its database or not, which type of database table they are managing. In their log files, which type of information is stored. So using JADX, this is known as DEX to Java decompiler. What is DEX? DX is your APK file. Okay, each and every APK file is having DEX file. It will convert that particular DEX to exact code associated with the implementation. It means that particular code that is developed by the developers. For example, so you can use these platforms for teaching also. For example, you are teaching Android programming, you are teaching IoT programming, and you want to show to your students by which way professional coding is done. I want to see the coding of Google Pay. I want to see the script or backend database tables related to PhonePe, Google Pay, Paytm, or any particular app. So using JADX. Okay, so that we can work with. So I will show you this particular demonstration. So this software I have already downloaded. You can download it from here in free and open source distribution. Okay. So in this particular folder, you can see this JADX utility, and we will execute it. So we will simply double click it. Simply double click and you will see this one is the toolkit, this one. So JADX GUI, and which software we want to fingerprint, from which software, from which APK we want to extract that particular code or data. Fintech. So one APK file I have downloaded for demonstration, and I'm opening it in JADX utility. So you can see that this one and main activity. So you can see that complete code, complete script is available. Log activity. Now these all of these files are available, which are written by the programmer at the time of development of this app. Now I want to see in which files it is asking for credit card data, in which particular files or in which scripts it is asking for UPI pin, whether it is saving your password or not. So text search. So you might have seen that every APK file and every Android app is having hundreds of files. Okay, so these are so many files. If I take Dream 11, you will get thousands of files, thousands of Java files. If I will take PhonePe, there are hundreds of Java files. I want to see only those files which are having this particular term. Okay, for example, pin. So it will extract all of those files which are having this particular keyword pin, so you can see that, or password, and at bottom you can see that it is decompiling, it is taking that particular data, and very soon you will see this one. Okay, password, or pin, okay, or pay. If I want to see only those in which some payment is associated, okay, so this one. If I want to see some particular scripts, some password, you can see that this one is the password, username, this one in same format, insert into. We want to move into the database tables, in which files insert into script, insert into statement, SQL statement is given. Okay, so you can see that insert into all SQL queries. So you can see this one password, admin password, this one is the username, this one is password. So different usernames and passwords which are already stored, we can view. So you can imagine how much vulnerabilities are there in this particular app. Okay, it is taken just for demonstration. Okay, is this visible to all of you? In chat window only, kindly confirm. Only in chat window, kindly write, because so many participants are online here. Is this visible and clear to all of you what we are doing? App data extraction. Okay, so you can see any app, you can upload app of Google Pay, you can upload APK of Phone Pay, anything. Simply take its APK file and upload. And if I and with these platforms, clonings are done. If somebody want to make clone of app, okay, so modification in this code, and after that recompilation, and then it is done. Okay, so you can explore this tool, JADX, and so many other utilities available. So these links I have given. Cloud-based decompilers also available. CC APK tool. Okay, so I will not cover all of these tools one by one because it will take lots of time only in single segment. Okay, because in cybersecurity, in data extraction, lots of things are associated, and I want to cover those also. So I will show you. So few demonstrations I am showing, and other alternate resources I will give you in this presentation. Okay, otherwise if you will focus on single segment APK analysis, it will take lots of time and entire session may be consumed in that. Okay, so simply upload APK and it will be done. Now we will see second segment related to data extraction, information analytics, prediction of malware using machine learning or deep learning. So this in this particular second segment. So one part that is related to live data analysis, live data extraction from APKs, from smartphone apps. But when we discuss about data analytics, data science, data engineering, then many times we have to integrate data sets. We have some data set, and on that particular data set, we want to analyze anomalies. We want to identify malware. We want to identify suspicious network traffic using machine learning or deep learning, which are part of artificial intelligence. In using machine learning or deep learning, there are so many concepts available: supervised learning, unsupervised learning. But before that, there are some certain requirements. If we want to go for data extraction from some particular network log, some network traffic, if we are having data related to lateral movement means by which way a particular hacker or particular cracker is moving its path from X machine to Y machine, Y to Z, and Z to W, and so on. So for that, there are different ways. One way is that we can take our own data. Okay, when we work with data analytics, there are two ways. There is one query. Can we do this to extract data from real device? Yes, on a real device also you can work, but in that particular case, you should be having APK file. So simply for whatever APK you want to analyze, you can download and you can uh, go for its data extraction. Okay. If you want to go for extraction of data from real network devices, then we can work with Snort, we can work with Wireshark. So many open source toolkits available. If I want to download live data from a network environment, Wireshark, this can be done. Okay. So in a particular network environment, we can install it and network traffic can be identified. So this is one way if we want to take live data from hotspots, from Wi-Fi. In alternate, we can work with some benchmark data sets. There are lots of benchmark data sets available for academic research, for corporate research in this particular segment. One of the very popular source of benchmark data set is IEEE data port. If we want to go for malware prediction, if we want to go for network traffic forensic, network data analytics, I want to train a particular data. So we can take that data for training from IEEE data port, from GitHub. So many links I have given here, from Kaggle, from SecRepo, even threats.kaspersky.com. So all antivirus software, they provide virus definitions, virus signatures. Okay, so if we want to take a particular data related to malware, simply you can search and it will be available. So you can see that this one. If you want to take a particular data related to binary files related to IoT gadgets or Android files, Telnet, Honey Cloud, and we can implement our algorithm. So in academic research means to achieve any degree, we generally take these benchmark data sets for training. Okay, Android malware data detection. For example, this particular data I want to train. So all of these data sets are completely free. So Android malware detection data set 2.29 MB, you can download it. Okay. Or so many other platforms available. If you want to get your own data, if you want to fetch your own data for training, in that case, we have to use Wireshark, we have to use Snort, and so many other software. But in academic research, generally we go for benchmark data sets because these are pre-tested, these are already tested. Okay, IEEE data port, these are the data sets related to Android malware fingerprints, Kaggle data sets. And once these data sets are downloaded, then we can train a machine learning model. As far as implementation of AI is concerned, as far as implementation of machine learning or deep learning is concerned, any approach you can use depending upon your implementation. So one data set I have, one particular data set I have already downloaded. So you can see that this one is the data that I have taken from IEEE data port. So this one is Excel sheet in CSV format for Android malware. So different key points are given, and it is of type binary classification. Okay, so many records, and we want to train this data, and this one is testing data. Some but few testing data sets available. Okay, now it's up to our implementation whether we want to go for supervised learning or unsupervised learning. If you want to go for unsupervised learning, so first of all, we should be clear where unsupervised learning is implemented. So I'm showing you that data set also for unsupervised learning. Okay. For example, this one. Network traffic. Okay. Just for demonstration, I have taken some data sets. So this one is the data set. If I want to find out anomalies, if we want to extract abnormal traffic from this particular data set, okay, so at one point we are having this data, at another point we are having this type of data. So this data related to binary classification that we have taken from IEEE data port, this data that is captured by log files, by Wireshark. And if I want to identify abnormal traffic, I want to identify abnormal fingerprints. If I'm having only this data, in that case, we have to use unsupervised learning, because in this particular data, there is no label. In case of supervised learning, you might have seen that we are having some labeled data. That labeled data we train. Okay, so both implementations I will show you. So first of all, we will discuss about this part, what this data is all about, and which type of attacks may be associated with this data set. You might have heard about a particular attack. So I'm typing here. That is known as zero-day attack or assault or exploit. Zero-day attack or exploit. In case of zero-day exploit, zero-day attack analysis, okay, there is no prior information on malware fingerprint on that particular signature, traffic signature. You might have seen that many times even top level cyber investigation agencies can't detect a virus. Developed very fresh. For example, I have created one virus, we have created one malware, and there is no information, there is no labeling, or there is no fingerprint of that type of attack so far. So cyber investigation agencies will not be able to detect that attack. Why? Because it will be 0 day. 0 day means there is no prior information. There is no prior details about that attack. By few modifications in script, by taking new exploit, a new executable is generated and it is deployed. So at very first time, when a virus is deployed on cyberspace, that becomes 0 day attack, 0 day exploit. And it is very difficult to identify, it is very difficult to recognize 0 day attack. To work with this, we have to work with unsupervised approach. Unsupervised means we are not having its prior knowledge. We are not having its previous information. For example, this one is the network traffic. Okay, at some particular date and time, we have identified this one is source IP address, destination IP address, using which protocol, response time, how much data is transmitted. Now we want to see which particular data is looking suspicious, which traffic is looking, which record is looking suspicious. So if we are working on this type of implementation without having any prior knowledge of this traffic, it will be 0 day exploit analysis or ZDA analysis. And for this, we work with specialized techniques. And one of the very popular technique, one of the commonly used technique is isolation forest approach. Isolation forest approach or isolation forest algorithm. So in this particular data, it is just for demonstration. I have taken 30 records. Okay, 29 records. Okay, it may be 29,000, it may be 1 million records. Now, out of these 30 records, I want to judge the abnormal traffic. By which way we can work? So we will see, we will integrate isolation forest approach or algorithm that works with this particular paradigm, assumption of contamination. I will show you its code also. Contamination, assumption of contamination in code, in traffic. Okay. In isolation forest. Now these are 30 records, 29 records. I assume, okay, as a network investigator, we assume that there may be 5% or 10, not 10% is very high value. Okay, 5% is also very high value. We assume that in this particular traffic, 1% traffic, 1% record will be malicious, will be abnormal. That assumption is known as, or that assumption is associated with contamination. Contamination, 1% means 0.01. So we will put this value in code. So it depends on the data set. For example, we are working on credit card data, financial data, credit card transactions. We have 1 million transactions related to credit cards. So in that case, we assume that 5% transactions will be fake, 5% transactions will be malicious. Okay, so it depends on that. Okay, 5% means 0.05. This value we will put. Contamination of records. Okay, we can't say that 0% records are contaminated. We will not say that all transactions are genuine. In whether you might have seen that in whether we are working on NEFT data, on RTGS data, on IMPS, credit card data, any data. So we assume 0.02, sorry. Okay. Okay. So whatever it is, 0.1%, 0.01. Okay, so if we are having a particular data related to financial transactions, we are having data related to um, logistics management, we are having data related to IMPS or any cards. So we have to assume, and depending upon that assumptions, we work ahead in the code. Okay, so we will see by which way we can work. So this one is the data set, and I will show you. First of all, I will show you this particular script and how to work on zero-day attack analysis. Zero-day, this one. Okay, so I have opened this screen in this particular window in this way so that I can view your chat message also. So you can see this one in Notepad++. We are working with ensemble learning isolation forest using scikit-learn, sklearn. So this is sklearn, that is scikit-learn used for machine learning in our implementations. So using Python bindings, using Python code, we can work with this sklearn.ensemble. Ensemble, it is isolation forest is a type of ensembled learning. It is not classical learning, it is ensemble learning. Ensemble learning means merged, it's merger of different techniques. Merger of different techniques means if we are using only single approach, for example, linear regression, logistic regression, naive Bayes classifier, or support vector classifier, these are individual techniques. If we want to get high accuracy, to achieve high accuracy on large data sets, we work with ensembled approach. Ensembled approach means all possible permutations of data are analyzed. So you can see this one, using pandas, we are reading the file, we are reading this data set. So this one is network traffic 2.csv. This is network traffic 2.csv file. We are reading it, which protocol is used, what is the data size. Okay, and features, which features we are taking. This is this particular, and in any machine learning implementation, in any AI based implementation, we have to work with feature engineering. Feature engineering means out of this complete data, out of so many attributes, which attributes are most important. So I want to see, okay, it is only for demonstration. So data size and response time, these two parameters we are taking into consideration. Okay, for anomaly detection, data size and response time. Standard scaler, scaling, we are performing scaling. This one is data size, and so on these attributes we want to see anomalies, and we are going for standard scaling. Standard scaling, using standard scaling, these values will be converted in same range. So you can see that data size, this one is in separate. If I analyze its min max, so its min max is very high. Min max of response time is very low, from 0 to 0.9. Okay, or from here we can see from 0 to 10. Okay, but here values are starting from 800, from 1500. If I train this particular data, if I use this data in machine learning or deep learning or whatever it is, without standard scaling, then data size attribute will dominate the entire prediction. Why data size will dominate the entire prediction? Because its min max is very, very high. Response time, min max of response time is very, very low. So data size is dominating factor. So to avoid this dominating factor, we use standard scaling. So what standard scaling will do? It will convert all values in same range. For example, these values will be converted to -1 to 1. In same way, all of these values will be converted in same range, -1 to 1 or 0 to 1, so that no attribute can dominate the entire prediction. Okay, so it is mandatory. You might have seen in deep learning also. In deep learning also, we work with scaling factor. However, scaling in deep learning is quite different. For example, we are working on satellite images. We are having geospatial data. So our images should be of same size, same dimension. If I am taking 256 by 256, then all images should be of same type. It should not happen that some files are BMP, some files are JPG, some files are 256 by 256, some files are 28 by 28. So standard scaling is required. Even if we are training haphazard data at backend in script, we have to make this thing clear that at the time of training, data should be converted in same range. Only then it will work. Otherwise, we will get abnormal results. After scaling, you can see that we are coming to anomaly part. So assume 1% anomalies, contamination, isolation forest. We are taking isolation forest, contamination 0.1. So we are assuming that, okay, this one is contamination. How much, how many values may be contaminated? How many values may be corrupt? Okay, so, and if I execute it, okay, so I am opening my command prompt again for execution, and this 0-day exploit this particular data, 0-day exploit 2. Okay, that particular code that we have just discussed using isolation forest. So it will identify anomalies from this particular data, from this data. Okay, this one is command prompt, and these are the anomalies. These are the abnormal traffic. So you can see, so depending upon these two attributes, data size and response time, if I change this one, okay, so if I want to go for plotting also, if I want to plot the results on XY axis, so this one, so where are the anomalies? Zero to exploit. So now I will change this particular contamination. I assume that this one, that, okay, 0.5, contamination is 0.5. Then what will happen? This one. Zero to exploit 2 and this one. So if we are changing it 0.1 and this one 0.5, we are changing the contamination level. How many records, how many, which type, which particular traffic may be contaminated, which particular traffic may be corrupt. Zero to exploit, and it is executing, and you will see its outcome. Okay, so I will share all of these codes also, so that you will be able to work with it. All of these scripts will be available to you. So now with ensembled approach, so what it is doing, it is creating so many trees, it is creating so many permutations on that data, and then it is identifying. Okay, so in script it is mentioned that by which way we have to evaluate, by which way we have to identify. So it is taking, so because we have mentioned, we have changed this particular value, it is taking more time in analysis. Okay, it is taking more time in investigation, that how many records will be there related to this particular exploit. Any data you will be able to take. Same type of, if we want to work with a labeled data, and we are having some particular prints, fingerprints like this. Okay, so this one, for example, this particular data. Okay, in that case, in to analyze this type of data, we can work with deep neural networks. Okay, we can work with classical machine learning or deep learning. Okay, so you can see that it is identifying, okay, so many records by zero-day exploit using isolation forest. Okay, if I want to work with labeled data with deep neural networks, with the deep learning, in that case we have to use PyTorch or Theano or Keras or TensorFlow. Okay, so this particular implementation is done by scikit-learn. So in this code you can see we have used classical machine learning platform scikit-learn. If I want to work with deep learning, so I'm opening that particular code, malware prediction. Okay, for labeled data. If we have taken data from benchmark sources, so you can see that this one is my Google Colab notebook. In this Google Colab notebook, we are taking this training data. This is our training data. This one is our training data, and testing data. I want to take this testing data. Okay, I want to go for its prediction. Now, so first of all, we will connect this notebook, and you can see that we are using Keras. So rather than using classical machine learning, classical scikit-learn, we are using Keras. Sequential model for training. Which data set? DS1. Okay. Here also we work with randomization with scaling. Okay, so you can see random seed for randomization of data set, for shuffling of data set. Which particular model we are using, which particular activation function we are using? Sigmoid, ReLU, this one. And finally sigmoid. In deep learning, there are different concepts related to activation functions. Actually, activation functions decide the type of output. If I want to take binary output, for example, true or false, malware or not, in that case, we use sigmoid. So you can see we are using final activation function sigmoid. In between sigmoid, we are taking ReLU, rectified linear unit. Why we are taking ReLU activation function? To improve the accuracy. Okay, there is one query that related to suggestion of coursework or study required to do research in this apart, machine learning or deep learning. Okay, as far as these concepts are concerned, definitely lots of work is already done in machine learning and deep learning. So there are certain new terms which are nowadays very popular and very new. So I will cover that part also, machine unlearning. Okay, so first of all, I'm covering this demonstration. After that, I will come to that part, machine unlearning. So you can see, choose files. I'm taking that particular data, DS1. And after this, I will cover new areas in data extraction in data analytics. So we are uploading it, and it will go for data analytics. So this particular data we are uploading. So obviously, so as thousands of records there, so it is taking some time, and at each step it will find out the accuracy level. So how many epochs we have given? 25. And at each level we are getting the accuracy. This one. So in this particular data, as this is a particular benchmark data we have taken from IEEE data port, it is very accurate, and accuracy of this particular data trained model is 99.9%, quite high accuracy. And this one is testing data. And on this testing data, what are the outcomes? What is the prediction? So you can see that these are the predictions on this particular data. So few values in between 1 and zeros. And model accuracy 99.90. What is the prediction? These are the predictions. Okay, so these are the prints. So in between values, this one on testing data. Okay, if you are having labeled data, then we use deep convolutional networks. We can use deep neural networks. If we are having if we are not having any particular labeled data, in that case, we work with unsupervised approach. Okay, so now we will come to that part. One query as given here. How many of you are aware with this particular term? Kindly write in chat, yes or no. Machine unlearning. This is a very new area of implementation in artificial intelligence, in machine learning. Other participants, how many of you are aware with machine unlearning? So if you are doing research in AI, ML, in artificial intelligence, in data analytics, you can take this for your work. Okay, load, because very less work is done in this particular domain, machine unlearning. And obviously, if you will take this implementation in your work, there will be very good chances of very high quality publications, because as an academician, as a researcher, we generally struggle for good publication. So if I will write some algorithm, if I will execute something related to support vector classifier, related to deep convolutional network, or random forest, or whatever it is, so you might have seen very common messages, very common things will arise, that lots of work is already done in random forest approach. Everything is done in convolutional network. Everything is done in LSTM, GRU. What new you are doing? What new we can work? Deep machine unlearning and deep unlearning. These topics, these domains are related to privacy and security, to enforce privacy and security. So what we do? So first of all, I will give you one example where you can use, okay? And then you can propose some algorithm, you can propose some good implementation, and then we can publish our work. For example, one model is trained on model 1 trained on 5,000 records or 50,000 records. Okay, it is just for example. Model 1 is trained on 50,000 records. Its file is generated M1. M1 is the model. Now, because of some privacy concern, because of some integrity concerns, it is asked to remove some records from this model. For example, this particular data, this particular model is related to electronic health records. Okay, electronic health records with Aadhaar and income status. With Aadhaar and income status of patients. M1 is trained. M1.pkl file or pickle file, whatever it is generated by execution. Now it is told, it is directed by government agencies to remove all Aadhaar cards, to remove all Aadhaar numbers from this trained model, because this model is trained and it is also having Aadhaar number. It is also having, whether it is in binary format or whatever format, but it is available. Okay, or select. So remove selected at records or attributes from trained model without retraining. This is known as machine unlearning. Removal of selected records or attributes, and it is done by removal of points, removal of key points from trained model. This is machine unlearning without retraining the entire. For example, on 50 million records, one model is trained. After that, it is told to remove selected records related to some politicians, related to some bureaucrats. So one way is that after removal of records, we will retrain it. Other way is that from trained model, selected points will be deleted, selected points will be removed, and then that particular model will be available without retraining the entire model. Are you understanding this point? Kindly confirm. Are you getting this point? What we are covering here with unlearning. No need to retrain. Okay, without retraining entire model, only selected points from trained model. Okay, for example, some particular data related to voter ID cards. Okay, trained model on the on particular records of voter ID. Okay, so we want to remove selected voter ID cards, selected records from trained model related to bureaucrats, related to politicians, related to high profile persons. That will be unlearning, machine unlearning, without retraining the complete data set. We will identify selected key points and then it will be used. So one way is that what is advantage? What is advantage of unlearning? Speed. Okay, execution. Obviously, it will be quicker to use. Okay, quicker to use and secured. Rather than giving access to complete data again and again, because if same data will be given access repeatedly, it may be sniffed. So security will be there and quicker to deploy. Okay, so this one is the approach that you can implement, or you can work with federated learning, federated deep learning, or machine learning. Federated deep learning or machine learning means, however, there is a separate topic related to this topic. I will not cover it in detail. Okay, federated learning means distributed learning. Rather than giving complete data to single organization, we are giving data to multiple persons so that there is no monopoly on complete data set by anybody. Okay, monopoly avoidance. So you can work on these. And there is one query related to deep learning in modern threat classification and anomaly detection, specific architectures. Okay, as far as in deep learning, you can work with federated learning, and ensembled approach is also integrated. So as just now we have discussed about unlearning, you can integrate it. So multiple techniques, as far as if we will go for classical machine learning, classical CNN, classical GRU, lots of work is done. So so with ensembled, federated and unlearning architectures, we can improve the existing performance. Okay. So, dear participants, now I am sharing this presentation to all of you. I am sharing these codes to all participants and presentation so that you will be able to work with it. So I'm sharing it, this one. However, lots of other contents were available with me, but because of shortage of time, okay, I'm sharing these resources. Dear participants, link of the presentation and code is given in chat window. Kindly confirm, is it downloadable or not? And if you have any query, you can ask. Dear participants, link of the presentation and code I have given in this in chat window. Click on this link and download. And confirm, is it downloadable or not? And if you have any query, you can ask. Any query from participants. Session is open for your queries. How can machine learning systems ensure explainability and transparency? Okay. Actually, nowadays XAI is also available, explainable AI that we can integrate. Okay, so that at each and every phase, we will be able to verify the records. We will be able to verify the outputs. So you can explore XAI architectures, XAI platform. Its toolkits are available, explainable AI. At each and every point, we want to verify the results. So if link is not working, you can open it in your mobile phone, because there may be some firewall in your laptop or some antivirus. And what strategies can be used to handle privacy concerns? Analyzing data for anomaly detection. Actually it depends on that particular data set, that scenario where you want to work with. Okay, so there is no specific thumb rule for privacy. It depends on the type of data, it depends on the location, and then we have to decide. And explainable AI, as far as explainable AI is concerned, so XAI you can explore. XAI for Python is available. Okay, so simply you can download its toolkit, XAI, explainable AI. Any other query from participants, and how much these tools are looking beneficial, these implementations look beneficial to all of you? Any other query from participants? If you have some specific query related to your work, you can mail you can mail me. In presentation, my mail ID is given. So depending upon specific scenario, you can take. Okay, so this question already addressed that in classification anomaly detection, we can work with merged or ensembled approaches, federated learning, and we can work with ensembled approach. Any other query from participants? After that, we will conclude this session.
Good evening, sir.
Yes, good evening, sir.
Thank you so much for the wonderful presentation, sir.
Thank you, sir.
Sir, can I know how to create the file bin? You shared one link in the group presentation and code. Like, you
Okay,
shared one link in a presentation code.
you want to download. So simply you can click and there is link to open. There is link to download zip file. So you can download that zip file. Okay, on your mobile you can download.
Sir, we already downloaded, sir. I want to
Okay.
know how to create that type of file. How to create that type of link, sir.
Okay. So for your students, it means you want to use it for your teaching, is it?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay, simply open filebin.net and upload any file, and in anonymous mode you will be able to generate link. Okay, and that link will you can share. Okay, so rather than mailing, rather than attachment, so simply we can create such some such cloud links and it can be shared.
Okay, sir. Okay. Is it free, sir?
Yes, it is completely free.
Is it similar to Google Drive link, sir?
Yes. In Google Drive, we have to log on to Google, but here it is in anonymous mode.
Okay, sir. Okay, sir. Thank you, sir.
So you can connect by mail also. You can, if you have any some more queries, you can mail me about your particular areas of research.
Oh, thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
So if there is no queries, should we conclude this session? Kindly confirm.
Thank you, Gaurav sir.
Okay. Thank you, sir.
Lots of appreciations are there in the chat box. So I'm grateful that you have spared the time. Your session has been treasure trove of knowledge. The real world case studies and practical applications you have shared have not only deepened our understanding of the role of the data analytics in the cybersecurity, but have also highlighted the significance of adopting innovative approaches to tackle the modern cyber challenges. So, sir, your ability to bridge the theory and practice has resonated with all of us, and I'm confident that participants have gained actionable insights that they can implement in their academic and professional pursuits. So, thank you so much, sir, and
Thank you,
see
sir.
you again on day after tomorrow on Saturday. Thank you so
Yes,
much,
sir.
sir.
Thank you, sir. Thanks to all participants.